Hi dear students, welcome to my YouTube channel. Today's topic is part 1 electric current and Ohm's law from chapter 4 current electricity. Before going to definition for electric current, we should know about atomic structure. So we know that an atom is the smallest particle of a material. It consists of centrally placed nucleus. The nucleus contains positively charged protons and neutrons which are electrically neutral. And around this nucleus, negatively charged electrons are revolving in various paths. We call these paths as orbits. So electrons in the outermost orbit, these are called as valence electrons. Whereas the electrons in the innermost orbit, these are bound to the nucleus, while the valence electrons are loosely bound. So as the valence electrons are loosely bound, if we apply a small amount of energy, valence electrons becomes free, and such free electrons take part in current conduction. And that's why these free electrons, these are called as conduction electrons also. And this flow of free electrons, it we simply called as current. So let us have definition of electric current. We define electric current simply as the rate of flow of electric charge. So we write current is equal to charge upon time, that is I is equal to Q upon T. SI unit of electric current is ampere. Unit for charge is coulomb. For time it is second. So ampere it is equivalent to coulomb per second. So electric current is measured by an instrument. We call it as ammeter. One important note is that electric current externally flows from negative terminal to positive terminal of battery supply. But when we have to show the direction of conventional current, it is from positive to negative terminal. So let us have definition for 1 ampere current from the basic definition of current. So we have current is equal to charge upon T, I is equal to Q upon T. So if Q, that is charge, is taken 1 coulomb, time is taken 1 second, then we write current I is equal to 1 ampere. That is 1 ampere is equal to 1 coulomb upon 1 second. So we define current flowing through a circuit is said to be 1 ampere if 1 coulomb charge flows through it for 1 second. Let us study Ohm's law. Before studying Ohm's law, we should know the various parameters related with a conductor. So if we consider various parameters of conductor like material, temperature, length, its cross-sectional area, if all these physical conditions, these are remaining constant, then current flowing through a conductor is directly proportional to potential difference between two ends of the conductor. That is, there is direct relation between current and potential difference. So we write simply V is directly proportional to I. We always remove the proportionality symbol and take a constant here. This constant, in this case, it is denoted by symbol capital R, called as resistance of the conductor. So we write V is equal to IR. R is a constant called as electrical resistance of the conductor. If we can plot a graph of current to voltage, then it will be simply a linear graph. Now let us have a comparison between conductors and insulators. Insulators, these are also called as bad conductors. We will define first. Conductors are the substances through which electric current flows very much easily, whereas insulators, these are the substances through which electric current does not flow. We have various examples of conductor, that is all metals, these are good conductors of electricity, whereas wood, rubber, plastic, paper, etc., these are insulators or bad conductors, no electric current flows through them. So conductivity of all conductors, it is very high, whereas conductivity of all insulators, it is very low. On the contrary, we say that resistivity or resistance of conductor, it is very low, and insulators has high resistance. Generally, we use conductors for making electrical wires and conductors, whereas insulators have applications as an insulation in electrical cables. Whenever we have to solve problems, we have two formula here. Basic formula for definition of electric current. Current is equal to charge upon T, that is Q upon T. I, here it is in current in ampere. If it is given in microampere, convert to ampere, multiplied by 10 raised to minus 6. If it is milliampere, convert to ampere, multiplied by 10 raised to minus 3. Q, it is the charge in coulomb. If again it is in microcoulomb, multiplied by 10 raised to minus 6. If it is nanocoulomb, multiplied by 10 raised to minus 9. T, it is time in second. If it is given in hours or minute, we have to convert in second. So 1 minute stands for 60 seconds. 1 hour, again it is 60 into 60, that is 3600 second. Second formula, it is from Ohm's law, V is equal to IR. V in this case, it is potential difference measured in volt. I current ampere. Again convergence of microampere and milliampere should be done. R is the resistance in ohm. If it is given in kilo ohm, multiply it by 10 raised to 3. If it is given mega ohm, multiply it by 10 raised to 6. So let us have first problem here. 300 coulomb charge is flowing through the conductor for 5 minutes. We have to find out the current flowing through it. So charge Q is given 300 coulomb. Time is 5 minutes. We have to convert in seconds. So 5 into 60, that is 300 seconds. We have to find out current I flowing through it. So we use basic definition for current, that is I is equal to Q upon T. Substitution values, we get I is equal to 1 ampere. A current of 20 milliampere is flowing through a bulb for 1 minute. We have to find out the charge flowing through the circuit. Again we use the basic definition for current. So current is given 20 milliampere. We have to convert it into ampere. So 20 into 10 raised to minus 3 ampere. Time is given 1 minute. So it is 60 seconds. We have to find out charge, that is Q. We use the same definition for electric current. I is equal to Q upon T. So from that, Q is equal to I into T. Substitute the values. You will get answer Q as 1.2 coulomb. Third problem, a battery of EMF 6 volt is connected across a resistance of 12 ohm. We have to calculate current flowing through the resistance. EMF, again it is electromotive force, that is potential difference. So we write V is equal to 6 volt. Resistance is given 12 ohm. So R is equal to 12 ohm. We have to find out current, that is I is equal to question mark. So here we use simply Ohm's law, V is equal to IR. So I is equal to V upon R. Substituting the value, we'll get I is equal to 0.5 ampere. Fourth problem, a current of 0.8 ampere flows through resistance of 30 ohm. Calculate the voltage across it. So current I is given 0.8 ampere, resistance R is equal to 30 ohm. We have to find out voltage, V is equal to question mark. Again we use Ohm's law, V is equal to IR. Substitute the values of I and R. You will get value of V, voltage, as 24 volt. A current of 1.2 ampere flows through resistance if a battery of EMF 8 volt is connected across it. Calculate the resistance. So current I is given 1.2 ampere. EMF, that is voltage, potential difference, is given 8 volt. We have to calculate resistance R. Again we use Ohm's law, V is equal to IR, or R is equal to V upon I. Substitute in the values, we get resistance as 6.67 ohm. Let's have certain MCQs related with this electric current and Ohm's law. So electric current is defined as, we know that electric current, it is rate of flow of electric charge. So electric charge per unit time, that is option D. Current 1 ampere is given by, we have electric current as rate of flow of charge. Current is equal to charge upon time. So 1 ampere, it is equal to 1 coulomb upon 1 second. Low resistance means dash dash and high resistance means dash dash. We have seen that good conductors, when we consider conductors are the substances through which electric current flows easily. So conductors have low resistance, whereas substances through which electric current does not flow, these are called as bad conductors or insulators. So insulators or bad conductors have high resistance. So low resistance means good conductors and high resistance means bad conductor. Ohm's law is valid when temperature of a conductor is. So in Ohm's law we have seen the 4 parameters of the conductor, that is physical conditions of the conductor. In that, temperature of a conductor, it should remain constant. Ohm's equation is, so we know that Ohm's law gives the equation V is equal to IR. Rearranging it, we can say it is R is equal to V upon I, that is option D. The rate of flow of charge is called as, so rate of flow of charge, it is the general definition for electric current, that is option C. Electric current in a wire is the flow of dash dash electrons. So we know that in any atom there are many electrons. So valence electrons, these are loosely bound. When we give sufficient amount of energy, these electrons becomes free, and such free electrons take part in current conduction. So we say that electric current in a wire is the flow of free electrons. The instrument used to measure electric current. So ammeter measures electric current. So option B. Electric current originates from which part of an atom? So electric current, it is due to negatively charged electrons which revolve around the nucleus. The ratio of voltage and electric current in a closed circuit. From Ohm's law we have seen that V is equal to IR, or V current is directly proportional to voltage, ratio of voltage to electric current, so it always remains constant, which is resistance. The graph representing Ohm's law is, so graph of Ohm's law, it is linear graph. Resistance is a measure of material's opposition to. So resistance, it is the property of opposition to flow of electric current. So it is material's opposition to current. A charge of 600 coulomb is flowing through a circuit for 5 minutes. Calculate the current in the circuit. We use the formula from basic definition of current, I is equal to Q upon T. So substituting Q is 600 coulomb, time is 5 minutes, so 5 into 60 seconds. So we get I is equal to 2 ampere. So option B is correct. A current of 0.5 ampere is flowing through a bulb for 10 minutes. Find the charge flowing through the circuit. Again we use the same definition for basic definition of electric current, I is equal to Q upon T. Here we have to find out charge, that is Q. So we write Q is equal to I into T. I is 0.5 ampere. Time is 10 minutes. Convert to seconds, so 10 into 60 seconds. So value of Q, it becomes 300 coulomb. The resistance of a conductor is 10 ohm and potential difference across it is 20 volt. Find the current flowing through the conductor. So here to find current we use Ohm's law equation, that is V is equal to IR. So I is equal to V upon R. V in this case it is 20, resistance is 10 ohm. So we get I is equal to 2 ampere. A current of 0.3 ampere flows through a resistance of 50 ohm. Calculate voltage across it. Again we use Ohm's law, V is equal to IR. Value of current is 0.3, value of R is 50. So substituting always we get V is equal to 15 volt. Thank you for watching. If you like this video, you can like and subscribe my YouTube channel. Thank you very much.